All right, welcome to episode 2 of Bite-Sized Biocompatibility. Have we got a good one for you today? We are going to be talking about the risk management process, everything ISO 14971 related.
I think I'm going to add in there, we're going to try about 14971 and do our best, since it is definitely probably one of the most underutilized and misunderstood aspects.
And oversighted, I think I want to say as well.
Yeah.
You see it everywhere within -1, and the whole principle and the whole foundation of the biocompatibility evaluation is based on this risk management, this 14971. But I think it's, as Beau just said, it's one of the most misunderstood or just
misutilized everything.
Just not understood concepts in the industry. So enjoy, you can learn along with us. Hello and welcome to Bite-Sized Biocompatibility, the educational series focused on making the technical content of medical device biocompatibility digestible. My name is Leah Williams.
Hi, and I'm Beau Rollins with Intrinsic Medical Group, and we're excited to take you along on this journey.
All right, everybody, welcome to episode 2 of Bite-Sized Biocompatibility, the educational series where we take the technical concepts of biocompatibility and break them down to make them more digestible.
Bite-sized.
Bite-sized, exactly. And
so today, what are we talking about today?
We are so excited to talk to you today about risk management, biocompatibility as a risk-based approach, right?
Risk management.
And anybody who has had a look at ISO 10993-1 will immediately have seen reference to it being a risk-based approach, right? Following the guidance of ISO 14971. So let's jump right in and get started. What does it mean? What does a risk-based approach mean?
This is I feel like this is the $1 million question oftentimes in medical device. It's the coined phrase that everyone loves to use. And then when someone says, well, show me your risk-based evaluation, and then it gets quiet and crickets come out.
Yeah.
It's definitely, and we love the 5, it's not letters, it's number, the 5 numbers, 14971. That's the reference that everyone likes to make. And then oftentimes when you ask someone, have you read that standard? And then you get the glazed over look a little bit, and they're like, well, it's all about risk.
And part 1's referenced it, right?
Yes.
And so lucky for you that if you are following -1, then because it was written in compliance with 14971, you are following a risk-based approach. So thankfully, you've got that saving grace there, but it is worth still having a look at ISO 14971.
Completely agree. And yes, that's a great way to point in that honestly, the main driver behind the 2025 revision of our -1 now was to align with 14971. That was always like the flawed point we talked about in episode 1, how everyone does checkbox, no one actually does an evaluation. And part of that was the thought was that the 2018 version wasn't really rooted into 14971. I don't want to say it all, but it just wasn't really rooted into it very well. And so that was the main premise behind the rewrite of 2025, was to actually bring it in.
Mm-hmm. Do you want to let that wind just calm for a second?
Oh no! Technical difficulties.
Yep. All right, where were we?
Wherever you left off.
Before the tent started blowing away.
No,
Right.
What is risk?
Yeah, okay. I can't remember what we just said, but I think, what is risk? So risk, from my understanding, is the potential for harm through device use or through a certain situation. If we're looking more generically, like in medical devices, it would be looking at that potential for a device to cause harm.
Yeah, and I mean, when we talk about risk itself, medical devices have been using risk assessments in almost every aspect of manufacturing design. We start with design risk matrices, which is going to be looking at the different ways the device could be used, what it's used on, and what happens if it's used poorly, if it breaks, if there's misuse behind it.
Yeah.
All that to determine, what would be the outcome or projected outcome. And can we design ways to mitigate that? And that's where you hear with risk is mitigation of risk, right? What can we do to lower those potential behind having that failure or that negative impact?
Yeah, and I think something that you kind of like included there, but is really key to kind of point out as well, is that there are two components to risk. Firstly, the probability that the harm is going to occur, and then also that severity of that harm. And that's ultimately with the patient contact classification that we establish within our biological evaluation process, we have having a look at that probability of harm there, and then having a look at those biological effects relate very much to the degree of harm.
Do you know, I was genuinely surprised after starting into sterilization and into biocompatibility. I was pulled into manufacturing later on and started to look into like clean rooms and cleaning processes and other things. And they were utilizing, PFMEAs to be able to evaluate with these processes, looking at all the different things that go through and what are the risks associated with those, the probabilities behind those, to determine which ones are low risk, medium risk, high risk. And then if they're high risk, what does that mean? If it does fail, is it just that the line shuts down? Or if it does fail, does it mean that we have a patient impacted? And then looking to either test or change or fix things around that to lower the risk or verify the risk. And I remember going through all of these and thinking, holy crap, like this is like very like diverse and it's very deep when you start going into all these and thorough. And we don't do anything like that really around biocompatibility.
Right. The rest of the medical device industry is really going into these in-depth evaluations, and that's what makes it even more frustrating when in biocompatibility evaluations, often we see it that we're just being asked to checkbox and tick off something that has shown that we have considered risk. For those who aren't watching the video, I'm making little quotation marks here. For those I've just checked off that risk related per the checkbox list.
Yeah, no, you're 100% right. The checkbox approach is what we talked about in episode 1 about being the wrong thing to do. Isn't a risk-based approach at all, in fact. No. And that's what led to a lot of the problems initially. Like, you should be able, as part of your biological evaluation, to set up and identify what potential biological risks are associated with the use of your device. And from the materials, the design, and the use, be able to assign, your severity and your probabilities behind those, and then determine whether or not you have a low, medium, or high risk. And with those, the low ones, in theory, shouldn't need to be tested or evaluated. The moderate and high, depending on what risks is associated with those, would need to be, and that should drive then what tests that you do. Mm-hmm. The thought of taking that type of approach to a regulator, I think, is probably about as foreign in biocompatibility as you can get. Yeah. And honestly, I'm not entirely sure what a notified body or the FDA or any international regulator would do if you submitted a true probability severity evaluation of your device and use, mitigating your endpoints just out of that approach itself. Mm-hmm. If they're familiar with those approaches used in other processes, I'd like to think they would be successful. Yeah. But if they're not, then I would fear that your response would just be, follow the test and
do the testing table. Right? Yeah. No, you're absolutely right. It does feel like an incredibly foreign concept to put together a risk matrix table as well. But it feels like with the latest revision of 10993-1 that we are really pushing more as an industry towards risk-based approaches. So I'm just curious, going a little bit off like the technical theory, just what would your thoughts be? Where do you see the industry going? Do you think that could be a future possibility of?
I sure hope it is.
Biological evaluations.
Because I really feel like we do ourselves a disservice and the patients disservice when we just try to do set tests. Especially if I'm doing a test that has no value to the device or the use, then we're just wasting money, and hopefully they're not in vivo studies where we're using animals as well. I think MMP is a prime example that we can talk about later in a later episode, but where that generally would have no value add and we're just utilizing animals, as part of the checkbox approach.
Yeah.
But having a true risk assessment means that we're doing the right meaningful tests. And it would also encourage that if you're going to perform like a systemic toxicity test, that I'm going to be setting that up to actually evaluate the risk I identified from the use of the device. So maybe the risk is specific to an organ, right? Or to a certain part of the body. Maybe it's through the duration of the use. And that should all drive then the structure and setup of my systemic toxicity test. So I can actually evaluate that risk rather than me running like a standard, 72-hour acute systemic toxicity or a 14-day, 14-dose IV, which may not have any relevancy to my actual use and risk of my device. That is what I would hope for the future, is that we can have purpose-driven tests.
Right. Keep it scientific, keep it accurate, keep it appropriate.
Yes.
Yeah. I think
should create an acronym for that one.
Yeah. What? SAA or something. Scientific, accurate and appropriate. There we go. I coined it. You heard it here first. I think with having the risk-based approach and kind of like operating within the risk management outlined per ISO 14971, it is also important to note that, as we also mentioned in our previous episode, that biological evaluation isn't about getting your device to a place where there's no risk associated with it at all. It's about reducing the risk and making sure that the any outcomes are appropriate to the patient, any response is appropriate, going back to that definition of biocompatibility as well.
Yeah, and I think the birds are all in agreement with you.
Yeah.
I hear them chirping right along that, this isn't about no risk. We have to always keep that in mind. Something can always go wrong, or maybe not even wrong. Maybe that is part of the use. It's just that in order for the therapy, which is intended to be better off for the patient than without, is acceptable on whatever that cause or that harm may be.
Right. And I think an example there that comes to mind is, say, for example, using a wound dressing or something, although we might have to think of another one since we already used wound dressing.
That's all right.
Like, it does irritate the skin to have an adhesive sticking the wound dressing to the wound, but it's much better than getting infections, to protect the wound bed as well, for absorbing any exudate that's coming out. So 100%
agree. You run into quite a few, if we want to look at an infusion device to change it up. I mean, it's the same principle with the adhesives, right? Like if I might get localized irritation where that adhesive is touching the skin, because the skin responds to that adhesive in that manner. But without insulin, the diabetic patient is not going to do well, right?
100%.
And the current, therapies out there with pump systems and that can be sent to constant monitoring and things, it's so much more efficient and effective and safer for the patient over the lifetime to have that type of system, that a localized irritation is okay. But you do oftentimes run into during the submission where the response is, no, you have irritation, you can't.
Yeah.
And why? Why not? Why would that irritation not be appropriate, if we're saving a patient's life and improving their well-being as well, enabling them to be able to be more active and to be safe out where they're not having to try to carry bottles and needles and everything else to manage manual injections of insulin.
Yeah, absolutely. Yeah, so I think that is actually a huge frustration that a lot of people have in the industry, is that expectation of there being no risk associated with the device as well. And I think we've quite clearly made our point that just isn't firstly achievable in a lot of devices, but also isn't necessary because of the therapy. We want to cause as little harm as possible when delivering these therapies during device use with the patients as well. But ultimately, if there's a greater benefit than the risk, then the patient is going to choose to use that.
Yeah. I mean, the mindset behind this, and I guess I'll start first by saying that, with 14971 and risk, there's the spirit of the law, and then there's the actual implementation of it. And the spirit is intended to be able to, look across and be open-minded and to be able to make individualistic determinations that are appropriate for what's intended in using. And then unfortunately the letter of the law that gets implemented is, as we've talked about, is just blindly going. So for all the people listening who's new to this, it can be very daunting because you'll hear us, you'll hear other people in the industry talk about like you need to do proper risk assessments. Don't just do a checkbox approach. And so you want to go in there and follow through with this. But then, when you get to regulatory submissions, your regulatory team and others are like, no, you must do all of these tests. And you're stuck in this middle of, do I follow the intent of the standard and what we want to do, or do I follow what is being requested or expected?
Right. And I guess that kind of like leads to the question of like, if the rest of medical devices is following a pretty thorough risk evaluation based process or risk mitigation, risk management based process, why is it that in biocompatibility, this is something that we could do a lot better on?
Yeah, it's the $1 million question, the one that we can't seem to answer because we keep trying to revise, we keep trying to push this, but the actual implementation refuses to change. And so we're always stuck in this hard spot where organizations, and rightfully so, it's a business and they don't want to have to pay all the extra money and spend the extra time, allowing us to do a true risk evaluation first and then follow up with additional testing when the regulators require it, or they don't want to fight with the regulators, right? They don't want to push back.
Right.
They just want easy submissions. And so it really is a catch-22 where until, we as an industry are able to move forward with that approach, businesses will not support it because it's not a smart business decision, and regulators won't accept it.
Right. But then we are sort of putting ourselves into a little bit of a corner, as you said, with catch-22, where, the majority, or my impressions of the industry, the biocompatibility industry, is that we don't really understand how to perform a proper risk management or risk mitigation through the 14971 process. So by not practicing it, we're also not improving our ability to do it.
Agreed. I oftentimes like to ask when I've had employees and that around biocompatibility specialists, who has taken 14971 training?
Yeah.
Who has been to a 14971 training and looked at, or a PFMEA or any of those risk-based evaluations,
or even read just 14971 or the kind of like the technical standard that goes with that as well, 24971.
Yeah. And it would be an interesting poll if we could do it anonymously out there to all the industry and just say, who here has actually done training in this area,
or even read it,
yeah. and see what kind of response we get. Because I think it would be, maybe I wouldn't be shocked now because of the feedback I've heard, but I think for most it would be shocking to see how few actually have.
Yeah. Shocking, but also not totally unexpected. All right, so that kind of like gives a little bit more of information about performing or doing a risk assessment within the risk management process outlined by 14971. But how are we actually supposed to conduct an evaluation within a risk-based framework? So we've talked about putting together kind of like risk-based tables. We've said that actually, if you are following the -1 guidance, it was written in a way to make sure it is in compliance with 14971 as well.
Yeah. I mean, the easiest way is to utilize the table that's in 14971. It was actually adopted into the first initial drafts of -1. It has been modified.
Is it still there? Just as a side note, because I read 14971 just about a month ago, and I did not see any tables. I was expecting to see a table. Maybe it's in 24971. I didn't get all the way through that.
24971.
Okay.
Very good point.
We'll check up on that. It's just that because I was expecting to see some sort of equation or calculation or table or something, and I remember being surprised that I didn't see one.
It won't have for calculating in that, but like in the draft of -1, there's a table that goes through the steps of doing a risk evaluation.
Yeah. Oh, there's a flowchart.
Flowchart, yes. Yeah. So that is in there, and that's what you should technically follow. The calculations and matrices that are typically used for different risk assessment, those will follow under different principles under risk management. So like a PFMEA or PFMEA, however people want to say it. I hear it every flavor.
Can you define that acronym?
No, I cannot define that acronym. But
I wanted to jump in and be like, which, by the way, is this, but I don't know if I can define that acronym.
It's one of those acronyms I don't think anyone actually knows. No, there are people out there who are going to be like correcting me now.
Nobody
like, it
knows
stands for
the
this.
words.
But that's the reason why we use the acronym, because nobody wants to actually have to say what it is.
PFMEA.
Yeah, it's a process failure mode and effect analysis.
There we go. So
Say
yeah,
that 10 times.
you heard it here first. PFMEA is a process.
Process, failure, mode, and effect analysis.
Perfect. We got that clarified. You're welcome.
So, yes. Like if you go into PFMEAs, into some of the directions and guidance behind those specifically, then they go into more about severity and probability and what values and things to assign to those. And there's a lot of tables that have been created as part of that you can download and utilize that will calculate based off of those as well. And then there are through statistical analysis, other ways to do risk determinations and assessments. And there's some, I believe, with the CFRs. There's some guidance around there from the FDA.
Define it.
I'm not defining the CFR. Stop making me define every acronym. This podcast will go way too long.
Go ahead.
Now you're bothered. Now I gotta sit there and think about what a CFR is. Killing me, Smalls.
Just keep going. It's fine.
I can't now.
The audience is going to want to know. We're making the technical theory of biocompatibility accessible.
Code of Federal Regulations.
Code of Federal Regulations.
I'm not in regulatory, but yes. So, yes, your CFR, your Code of Federal Regulations, has some descriptions that there's obviously the people who specialize in this area. There are people who this is all that they do, and I'm not an expert in this field in this area. I think that's part of the reason that in biocompatibility we've struggled a lot with this is it's just not generally part of what we learn and what we integrate and do. We understand from a scientific perspective how to evaluate potential, right? To look at something and say, how likely is this to happen or not to happen? And if it happens, what happens from that? But how do we characterize that, define it, and write it out in a way? That is definitely an area that isn't defined in our standards for biocompatibility, and not something that I've really heard or seen people actively doing. It is something that further needs to be developed. Perhaps that's a technical standard or TS or TR that can be proposed later on, which I actually think is part of the -1. There is a technical committee for risk assessment that has been formed as part of this new -1. Whether or not they're going to go through and provide that level of detail and
this is how you do it,
writing out and how to do it, or if it's more defining what risk assessment means, that still remains to be seen. But hopefully that's something that we get.
Yeah, absolutely. It definitely sounds like a very valuable thing to be pushing further into. So what can people do today if they've listened to this episode, they've said, right, that's it, I'm going to make sure that I'm going to make the principles in 14971 more apparent in my biological evaluation? What is something that they can do? And I'm so putting you on the spot here right now.
I would say go to your design and operations validation teams because they're most likely going to be implementing and utilizing risk, or depending on how large your company is in that. There are people within your organization that should already be doing this as part of manufacturing processes.
So there are people who are trained in it already elsewhere.
Yes, there are people who are trained who do it. Whether or not that can be applied directly to biocomp is the problem, right? That's what we're discussing here is how does that translate to biocomp and how can we do that? And whether or not that will be accepted or not.
Right.
If you do as part of your evaluation. It is something that, like in my own personal evaluations and things, I have it set up and planned for a long time to implement into that. The reason I honestly haven't is because it's generally not accepted as part of regulatory submission. So ultimately I've held back.
Yeah. So right now, just get curious, get learning, and be ready for the future when hopefully it does come.